Okay, today we will have a group project, right? And then you have to identify problem and take a case study using advanced analytical model, where you have to get the data set and provide detailed solution using deep learning in artificial neural network. Okay, you have to provide step by step on how data been analyzed with deep learning techniques. Okay, and as a guide, you can use this cross-industry standard process for data mining, as we have learned in our class. Okay, so now we will have a presentation by group leader and group members. Okay, thank you. Please.
Okay, today our group is going to present neural network project, which title is Electricity Load Forecast. And I'm group leader Lee Jun Kiat, and my member is Muhammad Nur Fauzi bin Muhammad Fauzi, Tan Yi, and Wang Tan Le. And let's start our introduction today. Okay, so in this project, we are using the artificial neural network ANN in doing this prediction. And what we use is using a dataset we call individual household electric power consumption dataset. And what is this dataset is about the usage of the household, the electricity usage of the household. And the pre-processing step involved is converting the noisy minute by minute data into a clean hourly power average. And we are using a multi-layer NN which is a 3-layer of the NN. And the neural network model will able to predict the next hour of electricity demand based on the previous 24-hour data only. And we are going to measure the result of the model using the IMSD and the R-square. Okay. Then next is the step-by-step in Python installation guide. First, we are going to download the Python from the official website and then choose the suitable Python version and download the installer. Later, we need to run the installer and download all the files by the installer. Next, we need to verify the installation by open the command prompt and check the Python version and also the PIP version. So if until here, it will show the Python version, and if it shows means you are downloaded correctly. Next, before we proceed to our project, we need to download all the package, all the tasks needed. So we need to upgrade the package and list down and check the package. And lastly, which is recommended before you're going to start a project, we are recommended to set up a virtual environment so that every project they can have their own virtual environment. So we can create our virtual environment and download all the needed data, needed package using the PIP install.
Okay, so I would like to explain the deep learning approach we use in our project. So we are using the artificial neural network ANN with a Python and PyTorch. As you can see in the definition, the deep learning is a subset of ML that adalah the NNN with multiple layers, which is it progressively extract higher level features from the raw input data. So we have total of 6 layers, which is the input layer, hidden layer, activation layer, output layer, weight and biases. Also the learning technique, which is forward pass or backward pass. So like I mentioned before, our group using the PyTorch library to build our model for the time series forecasting. Next. So I will explain a bit on detail on each deep learning functions that we are using. The first one is the touch.nn.module. This is the base class for all neural network models in PyTorch. And next, we are using touch.nn.relu. So we use this to mitigate the vanishing gradient problem by retest the max of 0x. Next is the touch.nn.dropout. We use this one to create a random fraction of P neurons that are set to 0 during the training. Next is the model.forward. This one we use to define the computation performed at the every call of the model. Next is the touch.nn.mse loss. This is the loss function, which it compute the mean square error between the predicted and the actual value. This is to minimize the values during training. Next is the OPTIM.Adam, touch the and then the linear. We use this to perform the operation of that equation, where X is the input, W is the weight matrix, and B is the bias vector. Next is the touch.optim.atom. So we use this to update the model's weight and bias based on the calculated gradient from the loss function. Next one is the loss backward. This one is to compute the gradient of the loss with respect to the model parameters using back propagation. This one is the optimizer.step. We use this to update the model parameters based on the computed gradient and the optimization algorithm. And the last one is the model.training and model.eval. We use this to set the model to training or evaluation mode.
So I will present about the flowchart and the step-by-step analysis, findings, and the result. So this is the session 1 flowchart, data loading and pre-processing. So the first is load household power consumption data, then data cleaning and preparation, feature engineering, then normalize the data. So session 2 is sequence creation and data splitting. So first we create the sequence for architecture neural network and split data into train, validation, and test data. Convert to PyTorch tensors and create the data loaders. So the session 3 model definition and initialization. Define the ANN model architecture and initialize model loss function and optimizer. So the session 4 is a training loop. So we can see the for each epoch and set the model to train model. Then before the first in the train data loader, later move data to device, zero gradient, forward pass, calculate the loss level pass, then go back to optimizer step. The end to calculate the average training loss. So this is the session 5 validation during training. We set the model to eval mode for each batch in validation data loader. Okay, this is the session 6 epoch control. If the epoch complete, then we will evaluate the model on test set. So this is the model evaluation, prediction on test set, and inverse transform prediction, calculate evaluation metric MSE, RMSE, MAE, R2, plot training validation loss, and plot prediction versus actuals. So this is the step-by-step learning, analysis, and findings. The step 1 is data loading and initial inception. The step 2 is data cleaning and preparation. Because this step the step 3 is exploratory data analysis, and the step 4 is data preprocessing for modeling. The step 5 is model definition and training. The last step is model evaluation and visualization.
Okay, for the data analysis, the dataset we use is the household power consumption.txt. The normalization is the preprocessed data scaled between 0 and 1 using the min-max scaler for stable neural network training. For loading and cleaning, the data is loaded into the pandas data frame separated by semicolon. All the missing value, approximately 1.25%, are changed to question mark. Date and time are changed to only one variable called date time. The sequence creation, it creates a sequence function, transform the scaled data into input-output pairs. Each input is 24 hours window and the output is the global active power for the next hour. For the resampling, it changes the minute level to hourly mean, and the data split is 70% training, 50% validation, and 50% testing. For the deep learning model and training, the model architecture we use is the ANN defined by model PyTorch. For the resampling, changes the minutes into hours. For the input layer, it takes 24 inputs, means the 24 hour. We have 3 hidden layers. The first layer has 100 neuron, RELU activation, 20% dropout. Second layer is 50 neuron RELU activation, 20% dropout also. And the third layer is 25% neuron lead to the RELU activation and 20% dropout. The output layer has one neuron predicting the next hourly power consumption. For the graph, the blue line is the actual value and the green line is the predicted value. Next is the average global active power. The very clear blue line is the daily consumption, the orange line is for the weekly consumption, and the green line is for the monthly consumption. Next two graphs shows the global active power and global active power versus global intensity. For the next one, the explanation on findings, figures, and result. The missing data set, which is around 1.25%, is handled by imputation. The feature importance, time-based feature means the hour, day of week, and month significantly affect the power consumption. Global active power distribution, highly right skewed, indicating the generally low consumption with occasionally high peaks. For the autocorrelation, ACF and PACF, plots confirm autocorrelation daily, weekly, and yearly lags. Strong seasonality. It means higher consumption in the winter, lower in the summer, distinct pattern on weekdays versus weekends, and clear intraday peaks, means morning, evening, lower, midday, overnight. About the training loss, both training validation MSE consistently decreased over the 50 epoch, indicating effective learning and good generalization without significant overfitting. The loss is stabilized after the 10th epoch. The result of the model evaluation on test set is the MSE. We have 0.2352, RMSE 0.4850, MAE 0.3565, R square is 0.5266. For the visual validation in figure 11.1, the test set visually confirmed that the ANN model effectively tracks the consumption trends during peaks and drops, supporting the R square and lower error metrics. For the conclusion, this project is focused on developing an ANN model to forecast the hourly global active power consumption using the previous historical household data. The key finding of and model performance. The EAD reviewed a strong daily, weekly, and yearly seasonality in power consumption, along with correlation with global intensity and sub-meter metering unaccounted. Implying and future work, explore advanced model like LSTMS or transformers, incorporated external factors such as weather, investigate multi-step forecasting, and explore different data aggregation level on or assemble model for improved robustness. That's the final output of the ANN achieved, which is MSE 0.2352, RMSE 0.4850, MAE 0.3565, R square is 0.5266. That's all. Thank you.
So now is Q&A part, and I already prepared a question for our project. So the question is, what is the improvement in the future for our project?
So I will be answering the question. So in the future, this neural network-based electricity load forecasting model can be enhanced by incorporating the additional real-world factors such as weather data, calendar events, and consumer behavior trends. Transitioning to more advanced architecture like transformer or hybrid models could improve the prediction accuracy. Furthermore, the integration of real-time learning and deployment in the age of device would support the dynamic energy management in smart grids. And lastly, the inclusion of explainability features will build trust among the stakeholders and support decision-making in power system operations.
Oh, well, it's good. Thank you for responding. So, thank you all.